So in sub-exercise B, we are asked to find the optimal commodity taxes in this economy. So now what we are going to face is an optimization problem of the government. And yeah, what is the optimization problem of the government? Well, it wants to maximize total welfare such that it raises capital T units of revenue. Yeah, so you can also write this as some kind of an optimization problem with a constraint, which we will do now. Okay, so this is sub exercise B. So let me go here. So sub exercise B. Good. And I will use some slight abuse of notation here. So X1A star, so which is the optimal demand of consumer A for good 1, which was depending on Q1. I will set this equal to X1A star. Then the indirect utility function, so VA of Q1, Q2 will be equivalent simply to VA, yeah, so just a short notation, and the same thing for consumer B, yeah, so then we have X1B star and VB. So how does the optimization problem of the government look like? So the government is having the following optimization problem. It's maximizing its Lagrangian, which I will denote by LG, which depend on the post-tax prices of the goods, Q1 and Q2, and the Lagrange multiplicator for the government, which I will simply set to lambda. The government is maximizing over those endogenous variables, so Q1, Q2, and lambda. You could also write T1 and T2 here instead of Q1 and Q2, but typically what you do is you restrict yourself to the post-tax price. Yeah, so it would make such a big difference, but yeah, we stick just to the post-tax price here. So what is the utility function or the objective function of the government? So it's the total welfare, and here in the easiest case, it's simply VA plus VB. Yeah, so the sum of the indirect utility functions of the consumers. This is the total welfare basically in this economy. But we have a constraint which was given by the fact that the government wanted to raise capital T units of labor. Yeah, so this is something that we need to consider as well. So we add to this the following. So we add lambda times, now what we have is basically the tax revenue due to good 1, which is then the kind of the post-tax price of good 1 minus the price of good 1, which is 1, times the amount of good 1 which is consumed in this economy. So this is X1A star plus X1B star. Yeah. So then basically this is the so this here is the total demand of good 1. This here is the price of good 1. So the whole thing here is the total, so it's the tax revenue due to good 1. To this we add the tax revenue due to good 2. So we add Q2 minus 1 times the amount of the total amount of good 2, which is the minus, so X2 X2A star plus X2B star, and then this here is the price, the tax, the unit tax for good 2 times the total amount of good 2, and in the total this will be the tax revenue due to good 2. And from this we subtract basically the amount of tax revenue that we need in units of, in monetary units basically, because you can think of capital T here as the monetary unit or the monetary amount of labor needed, because we normalize the wages to 1 here. Okay, so this thing now is the optimization problem of the government. Now, if you plug in for the values that we derived before, we end up with the following expression. So we are maximizing over Q1, Q2, and lambda. So we maximize this objective function, or the Lagrangian. And if we plug in for the values that we calculated in sub exercise E, we have minus 3.45 minus 3 times the log of Q1 minus 2 times the log of Q2 plus lambda times 1.86 times Q1 minus 1 divided by Q1 plus 1.28 times Q2 minus 1 divided by Q2 minus capital T. And now if we solve this optimization problem, so we derive the first order conditions with respect to the endogenous variables, and we solve for Q1 and Q2, we end up with the following optimal commodity taxes. So we have Q1 star is equivalent to 3.1 divided by 3.14 minus capital T. And we have an optimal commodity tax for good 2, which is equivalent to 3.2 divided by 3.14 minus capital T. Yeah, and those are the optimal commodity taxes in this economy. And yes, as you can basically see, they are both strictly increasing in the amount of tax revenue which the government needs to get. Basically, yeah, and the reason is quite simple. It's because the only way that the government can raise taxes is by commodity taxes. So if it needs more tax revenue, the taxes obviously need to increase. And we can also solve sub exercise C here immediately. So let me go back 1 second. So in sub exercise C, we are asked to answer the following question. Is it optimal to discourage good 1 less than good 2? Why or why not? And the answer here is the following. So as you can see here, the taxes on good 2 are higher than the taxes on good 1. And the reason is simply given by the fact that if you look at the utility functions of the consumers, let me just go back here. If you look at the utility functions of the consumers, what you can note is that the utility that consumer A derives from the consumption of the first good is strictly higher than the utility that consumer B derives consumption of the first good, whereas for consumption of the second good, we're having the same here, and also the costs of labor here are equivalent. Okay, so the only difference is that I'm always mixing up firms and consumers. So what you can see here is that consumer A has strictly higher utility from good 1 than consumer B. And therefore, if the government wants to maximize social welfare, it should discourage the consumption of good 2 more than the consumption of good 1, because simply consumer A is getting more utility from the consumption of good A. Yeah, so basically the idea is fixing the amount of tax revenue that the government wants to raise. It can do this by taxing good 2 more, such that the social welfare is basically maximized. Yeah? So this is the reason why in this economy, the taxes on commodity good 2 are higher than the taxes on commodity good 1, which basically is the answer to sub exercise C.